Check testing 1 2 1 2 mic check. Alright, everything sounds good and looks good, guys. We're gonna go ahead and get into this. Let me just change over here. So, over the past hour or so, we've had convective initiation ongoing across portions of south central Kansas and north western Oklahoma, down through western Oklahoma, eventually spreading down through western Oklahoma and into even portions of Texas. We do expect this line to continue to grow upscale down into down from this area up here, and it's gonna fire down a line like this, and it's gonna fire down into Texas and kind of push off to the east in an easterly direction throughout the remainder of the night here. Um, these red boxes right here are is the valid tornado watch that is out right now, and I will kind of go into that here in just a second. We do have a severe thunderstorm watch up in southern Kansas as well, indicated by the yellow boxes here. I did not get around to changing my warnings on my radar yet, so red warnings are going to be severe thunderstorm warnings here, and I believe that purple is the tornado warnings on this program. I'm not sure. Warning settings. Yes, tornado warnings are pink and purple. Severe thunderstorm warnings are red. Green is flash flood warnings. Light blue is special marine. We don't need that right now. So, yeah. So basically, red and purple. That's all you need to worry about right now. And green if there's some flash flooding. So we do have a squall line. It's a line of broken supercells right now that's going to eventually be congealing into. We'll get a closer look here. A line of broken supercells. You can see how there's kind of this gap in between each little individual cell. Eventually, as there's a cold front back to the west that these are forming off of. And as this cold front collides with this line of convection, it's actually going to cause everything to solidify into one solid line, where we will have a risk for large hail and isolated tornadoes with any sustained updraft that can manage to develop inside this line. From some of the analysis that I was running earlier, it does appear that the updrafts or the storm bases are going to be quite elevated. However, there is enough bulk shear and low-level shear, as well as storm relative helicity, to support a tornado or two in this environment. Some of which could be potentially strong, depending on how well these root to the surface. As of right now, I'm mainly seeing more of a hail threat with these thunderstorms, especially with this cell here northwest of Arapahoe in Custer County, Oklahoma. It would be this storm right here. We do have a bit of range folding. If you look to the right side of the screen on the velocity, you can see how everything's all pixelated. We're not getting a really clean scan on that. That's because there's an area of range folding right here. So it's kind of distorting things past, and it's kind of distorting things that are close to this range folding. We're getting some pretty clean scans from Hollis all the way to the northeast of towards Elk City. Getting some pretty clean scans from this radar site. We'll see how well this goes. I did post some target areas, hypothetical target areas, if I were to be storm chasing. Um, I was planning on targeting the the southern portion of this storm, so the storms that are actually forming, that are going to be moving into this area, would be the ones that I would be most interested in. Um, the one that currently has my attention, though, is this one that's near Hobart. It's building a nice little core on it right now. Anything where you start seeing these pinks inside inside the reds, that's where you're starting to get into hail territory on the radar spectrum. Um, so when you're getting hail and thunderstorms, you're more than likely have a strong enough you have a strong updraft where it's actually lofting those stones and allowing them to grow to more than grapple, to more than pea size. So right now we're just kind of in the early stages of this. I mean, this storm blew up incredibly fast. It's a rapidly evolving line. That's for sure. I think that this northern side is eventually going to taper off and be more weak. I'm not saying it's not going to do anything, but we definitely do seem to have a special weather statement up here to north. Do have more of a broken, isolated, kind of discrete mode up here, but there's also less moisture and less favorable environment for strong thunderstorms up here, given there will probably be a hail risk and some damaging winds associated with these, maybe even a low end tornado threat just because of how backed the winds are. But your bigger threat is going to be um, this line of storms as it pushes to the east. As this matures, I fully expect a couple of QLCS tornadoes to form up in this as the line congeals. Um, Depending on how this goes, I mean, we could maybe even see a pretty strong mesocyclonic tornado off of a semi-discrete cell, just because this is a broken line of supercells. They have the ability to pull more inflow. So we do actually now have a considerable severe thunderstorm warning for portions of Woodward, and major counties in northwestern Oklahoma. This is going to include Waynoka, Arvard, Orion, Chester. If I could just get the warning text up here. Yep. Okay, so we are looking at golf ball sized hail and 60-mile-an-hour winds for Chester, Hopeton, Avard, Waynoka, Alva, I'm sorry if I'm butchering this, Bose Junction, Quinlan, and Orion. Um, this is moving 3 miles west of Chester, moving northeast at 30 miles per hour. And this is not just like one storm. This is like a whole line, so that there's like you might hit a lighter patch of the precipitation, but there's probably going to more than likely be 60-mile-an-hour winds pushing out from the entirety of this line, especially right here. And what they're probably warning it for is this stronger cell here near Waynoka. This cell right here, you see the hail core that's forming in it right there. We do have two stronger updrafts forming, maybe even three to the south of that as well, north of Mangum, south of Taloga, kind of in between that area. We're starting to see some pretty good development on the southern portion. As I'm saying that, they issue a special weather statement for the southern portion. I am starting to see a bit of rotation on this Carter storm. It's nothing crazy. It's nothing crazy. It's very broad. Wouldn't be too concerned about it yet, but this is going to be an area to watch right here um, for development later on. I do apologize. I've got like multiple chats and things going on. Your screen is probably going to go black for just a second while I adjust some things really quick. I don't want a bunch of dinging going on my PC. I guess while I'm over here, let's flip over and we'll do some analysis really quick to kind of show you guys who are into the more nerdy side of things what is going on with the atmosphere right now. If I can get my remote to work. You guys are welcome to share this live stream as well. I'm doing this specifically um, to basically get the warning out and to help educate people on what to look for when they're looking at this stuff. I'm a self-taught, been doing this since 2018, 2019, and been teaching myself everything I know. And I found it very difficult learning this stuff without help from others, and finding help from others that was actually worth something was very challenging. So if there's anything I can do to help someone learn or to keep somebody safe from doing this, then that's why I do this. Okay. So right now we have our surface observation map pulled up. Um, I won't do too much here because I'm going to do a lot of things that will explain this better. And actually, we'll do those other things first, and then we'll come back to the surface map. So, temperature, wind, and dew point. We can see that we have a closed low pressure, or closed surface low here at 988 millibars. And we're not going to map out every single front right here, but what I'm going to focus on mainly is this cold front. And then we also have this moisture surge that's coming up into Oklahoma, Texas. Oops, I'm going to redraw that. That's not going to satisfy me very much. Okay. There we go. Yep, nasty embedded supercells there, RJ. So you can see where that line, that most intense line is at right there. Right, let me get my pointer back. Right here. You can see that there's some nice green colors that those are running into. That deeper green colors is going to represent like I believe, let's see, about 68, 65, 68 dew points at the surface right there, which is really going to help any storm that's pulling surface inflow to have nice warm moist inflow to ingest to feed off of. So that's why those cells right here in particular are stronger than the ones that are, say, up here or down here. And I just cleared out my whole thing, so we're gonna draw that back, draw the cold front, roughly speed through this because we got to get back to radar. So another thing I like to look at is theta E. Not much theta going on here. Upper air chart, so 500 millibar. We do have a little bit of defluence going on here in the 500 millibar. Let's go up to the 300. Fairly laminar winds there. 500 millibar, starting to get a little bit of defluence. 700 millibar, fairly dry 700 millibar region. We're starting to get some backing though. 850 millibar. This is where your low-level jet is, and right now there's a low-level jet out in front of these of between 50 and 60 knots, which is more than enough. Especially these are southerly winds, so the winds are coming from the south and moving to the north like so, in such a direction like this, and they're moving in that direction at uh, 50 to 60 knots. Um, with the given storm motion, the the stronger inflows is going to happen when this southern region of the storm pushes east into the deeper low-level jets, those stronger low-level jet winds. Um, you actually might even target this storm if you were, because of the way that the bow is aligned. It's going to allow this cell in particular to grab some inflow and ingest it without being interfered by the stuff from the south. That's why on these line systems I like to target the southern storms, because they have a less chance of anything interfering with the inflow regions. So going back down farther, we're going to go closer to the surface, and you can see this. These green lines represent moisture or dew point, and you can see specifically right here. That's where our highest dew point is going to be at. So that region right there has more moisture for storms to feed off of. It has the most moisture for storms to feed off. So once storms enter that black circle right there, they're going to really start to be able to feed off of that lower level environment fairly well. Moving on to thermodynamics, we do have a capping inversion going on right now. So the storms are going to be elevated, but we've also got 1,500 joules per kilogram of surface-based CAPE. We also have 1,500 joules per kilogram of mixed layer CAPE, but there's still a capping inversion going on all the way from the surface base to the mixed layer. So that's going to keep the storms elevated. Lapse rates are a little bit lacking except for this southern mode. That's where lapse rates start to improve, actually. So I'm popping a quick skew sounding here. So this is the hodograph. We have winds out of the south at the 0 kilometers south southwesterlies, and then at the 1 kilometer we have south southeasterlies, and then we have at the 2 and 3 kilometer is southeasterlies, or south southeasterlies, southeasterlies, and the 4 kilometer or 3 kilometer. I'm not sure which one it is, honestly. Um, Almost west southwesterlies. So there's a lot of shear going on right here, a lot of directional shear. And at the 1 to 2 kilometer, you're having 50 to 60 knots. 30, almost 30 knots of southerly winds at the surface, just barreling into these things. We're going to, I just cleared all that out, my bad. We're going to look at the skew T. You can see right here, there's that temperature inversion. It's crossing over our CAPE line. That's going to cause the storms to stay elevated and even maybe even limit their potential some. So unless that capping inversion dissipates, these southern storms aren't going to get very strong. But if we go ahead and move that up to here, you can see that uh, capping inversion is a lot weaker. It's a lot more weak. But the cloud bases are going to be elevated as well to about 1,000 meters. But there isn't as much of a temperature inversion happening there. Lots of fat cape, fat cape. Nice little dry slot for the in the mid levels. Nice elevated mix layer. Deep effective inflow layer. And then you can see over here we have our winds turning with height. Deep backing in the low levels. We'll pop over to the hodograph, and you can see that represented on the hodograph. We actually have deeper shear here, better inflow to the north, with southeasterlies, south-southeasterlies, mainly in the lower levels in the inflow layer. You don't really get to the southwesterlies until about the 2 to 3 kilometer region. Storm relative motion is going to be northeast. At 50 knots. That's going to be, these are going to be screaming through Oklahoma. Absolutely jamming out. So if we'll go ahead and we'll look at the effective wind shear here. Got 70 knots of bulk shear, effective bulk shear out in front of these southern cells here. So basically anything in this portion that pushes east is going to have my main, my attention mainly for embedded updrafts. Go down to the 1 kilometer. We got better surface shear closer to the low. The low's like right here. So when you get closer to that low pressure system, your low level shear is enhanced quite dramatically. We got 40 knots of low level shear in that region, but we do have 35 knots of low level shear in that lower region right here, which is plenty for rotating updrafts. Not necessarily on a linear system, but this isn't quite linear just yet. It's more of hybrid linear, broken line, kind of isolated, discrete, if you will. And we'll look at the effective storm relative helicity. We're pushing 700 meters squared by second square of storm relative helicity in this region right here. So that's actually one of the reasons why why my hypothetical target was southwest Oklahoma, because when these supercells hit this SRH and the thermodynamics in place in that area, they're just I've theorized that they're gonna go crazy. Let's go multi-parameter fields. We're going to look at surface vorticity and 3 cape. So most of your 3 cape is limited to the northern mode, but a lot of vorticity down here to the south. So even though these might look weak on radar, they're going to have a lot of spin to them. A lot of spin. So we're going to look at conditional probability of a significant tornado. And I like to use the conditional probabilities just because I don't know, I'm more of a conditional guy. So we have a conditional probability of a significant tornado of 90 right here. And 90 right here. But all of the storms up here are past this area. And all the storms down here are in the area. So I would feel more confident saying that these storms have a chance of producing a tornado than I do the north storms. Not saying that the north storms won't produce a tornado, I'm just saying that less likely that the north storms will produce a tornado, given the amount of moisture and thermodynamics up north. Now, we can go to conditional probability 2, and that's still at a 70, keeping that supercell in particular in play. I'm going to go ahead and get rid of this big black line here. So that's going to be the storm we're watching for the most part. And I'm going to pop back over to live radar here and check and see our warnings and stuff because I haven't taken a look at that in a minute. So we do have a severe thunderstorm warning now in southern Kansas for ping pong ball sized hail and 60-mile-per-hour winds gusts. This is going to be for central Barber County in south central Kansas. This storm will be around Medicine Lodge around 10:15 p.m. Central Standard Time. Our storm that we've been watching on the analysis is going to be this one that's to the west of Hobart. And let's see here. So we do have a couple of areas of rotation trying to build up in this. It's really trying to do a QLCS type scenario here. And QLCS is a really hard to catch. So maybe if we go up deeper, we can see those rotating updrafts a little better. Yep, they just severe warned that that line that I was initially targeting for storm chasing potential. Really starting to get some nice embedded rotations in this. So like, let me get a better color here. So like this is broad rotation and broad rotation here. Couple little broad little kinks in here where it's trying to form up. And even down in here, you can kind of tell where there's like a couple little embedded. They're not very strong yet, but you can see where they're starting to pull RFDs or rear flank inflow. I've got to try and change the color of my chat because I can hardly see it. Appearance. Compact mode, click through mode, always on top, message opacity. I might just have to change the scale of the chat here. And we're gonna close, and I need to pull my, sorry guys, 1 second. I gotta change my background so I can actually see what people are saying here. Alright, that's slightly better. Alright, I can see the chat now, y'all. Give me just a second, guys. I'm gonna back this out so you guys can kind of see where these warnings are at. I'm actually gonna change the radar to a different site to kind of see everything a little better. And I'm gonna share this live stream out to a couple chats here. So we are getting some hail reports. We have a hail report of 1 inch in Custer County, Oklahoma, 1 inch in Roger Mills, Oklahoma. Source is going to be emergency management there. We're going to go back down to this southern radar here. As you can see, our line is starting to progress down into Texas a little bit. This line is eventually going, they anticipate this line to shift farther down south into Texas as the night progresses. As this cold front enters these higher dew points that are down to the south, we've got 61-degree dew points in Montague County, Texas. Let's see. I'm not wanting to see that. I want to see this. 62-degree dew points in Hood County, Texas. In Coryell County, Texas, 68-degree dew points, temperatures 70. So I mean, just the area out in front, like our cold front is running kind of along this axis right here. So kind of like this. That's our cold front. So as this area down here pushes into this red area, that's when we're going to start seeing storms pop along this blue line. You can see it's already starting to happen right here, and it's just going to keep expanding down. And they've issued a tornado watch for this scenario to unfold accordingly, indicated by this this red area. It's a 50% chance of 2 or more tornadoes, 20% chance of EF2 to EF5 tornadoes, 20% chance for hail over 1 inch. This is not a particularly dangerous situation. Watch. Tomorrow is going to be the big day, in my opinion. In my personal opinion, tomorrow is going to be ridiculous. We'll go into that a little bit more here later, more than likely, depending on how I feel. I did just get done having wisdom tooth surgery. I'm on about day 8 of recovery now, but my jaws are still killing me, guys. So if I have to take a break and stuff, I'm gonna take a break. I'm sorry ahead of time. If I do have to take a break, I will more than likely leave the radar up and running, though, so that you guys have a way to see what's going on if you don't have your own radars. And we are starting to see to the east of Hollis here a little bit of rotation starting to pick up near Gould. So green is winds that are on the right side of the screen here, on the right side of the radar. Green is winds that are moving towards the radar, and red is winds that are moving away from the radar. So you have winds that are moving towards and winds that are moving away. And when you get them coupled up like this, right here, that's rotation. That is counterclockwise rotation. All severe thunderstorms, well, not all severe thunderstorms, but most significant tornado-producing thunderstorms rotate counterclockwise. We're actually starting to see some of that going on down to the south as well. It's actually a little bit more convincing, actually. It's nothing significant. Don't get scared just yet. It's not anything crazy worrying, but this is definitely starting to look a little more convincing. These brighter colors mean stronger winds, right? So this is about 40 to 50 knots of winds here. Let me just pull out my tool to be certain here. The 49 knots. Yep, 49 knots. 40 knots. Well, nope, sorry, I lied. It's about 40 knots. And then over here we have, it's basically 0, but it is showing that the wind is moving away from the radar. So we're starting to have an inflow cut right here, which you can see on the left side. This is that inflow cut. So we're actually gonna, this thing might actually try to hook up into a supercell, an embedded supercell. So what we're seeing here is the winds are punching through the backside of the storm and they're blowing that portion forward. That's called a rear flank downdraft. Which is this right here. And you can see that those red pixels, even though there's only a couple of them, they're denoting that winds are moving away right there. And I wouldn't have thought much of that. I would have thought it was just contamination right there if it wouldn't have been for this feature right here. The fact that it's starting to bow up right there and make that shrimp looking feature on radar, and the fact that there's a hail core associated with this. That is signifying that there is a strong updraft right here trying to form. So we'll monitor that and see how that storm progresses. Definitely worth keeping an eye on that. Now, I'm also going to admit this right in the beginning of this live stream. I'm not going to try and catch every single tornado warning. I will eventually read out every single tornado warning, but I am mostly fixated on this portion of the storm down here because you can actually, you're starting to see the QLCS nature now starting to form because you've got curve here and a 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 curve here. All of those are eventually going to be updrafts, embedded updrafts. That's what makes QLCS so dangerous because you get these little itty bitty kinks, itty bitty rotational kinks, and sometimes they might not even look like much, but there's one, there's one, there's one, there's one, there's one, and they just keep going, and sometimes they're really hard to spot. Sometimes they won't even have red in them, but they'll be tornado warned. So, I mean, you gotta, once you've been doing this for as long as I have, you start to realize things. But there is actually a really strong updraft right here. This thing is gonna eventually try to do it. And that's pretty much where I was. That's pretty much the storm I've been waiting for. Is this portion of the line. This portion right here. Specifically this storm. When I was posting on Facebook earlier talking about my hypothetical storm chasing target, it would have roughly been this area right here where I would have set up at, and this storm right here is coming directly for that area. So I would probably be moving west now, actually, southwest, to try and get on this storm. But I also would probably be keeping my distance until it does gain a tornado warning or it gains a much deeper rotation on radar. Because you don't want to get right up on these things thinking, oh, this is the one, and then the one to the north of it, 20 miles, does it. You want to be in a position, if you're chasing, to bounce around if you need to. We do have a 1-inch hail marker on this now, so hail size up to 1.19 inches. And if you go up in the scans, I mean, that looks really good. Really good. That is a strong embedded updraft. And I'm actually going to send a screenshot to some people. Give me 1 second, guys. Screen might go black. Oh, my mic was muted this whole time. Well, I guess I'm going to read these out again because I think my mic was muted. I apologize, guys. So we do have 2 tornado warnings. The National Weather Service in Norman has issued a tornado warning for. Oh, just got an update on it. Sorry. Okay. Tornado warning remains in effect until 11:15 p.m. Central Standard Time for northeastern Custer, west central Blaine, and southeastern Dewey counties. At 10:38 p.m., a severe thunderstorm capable of producing a tornado was located near Custer City, moving northeast at 50 miles per hour. Hazard is a tornado and golf ball-sized hail. This is radar-indicated rotation. Um, Locations impacted include Thomas, Custer City, Oakwood, Eagle City, and Fay. If you are in those locations, you need to take cover now. This is a tornado warning for Thomas, Custer City, Oakwood, Eagle City, and Fay. We also have a tornado warning for northern Washita County in western Oklahoma, south central Custer County in western Oklahoma until 11 p.m. At 10:32 p.m., a severe thunderstorm capable of producing a tornado was located near Burns Flat, moving northeast at 40 miles per hour. Hazard is tornado and half-dollar-sized hail. This is radar indicated at this time. Locations impacted include Corn, Bessie, Clinton, Burns Flat, and Dill City. This includes Interstate 40 between mile markers 60 and 73. Take cover now. We do have some rotation starting to build up near to the north of Mangum, west of Granite. I imagine that this portion of the line these are going to pop probably from north to south along the line as they move into the better dew points that we were talking about earlier on our analysis. So we're probably going to see a warning pop here somewhere, and we're probably going to see a warning pop here somewhere, and probably see a warning here somewhere, and eventually down here and down here as well if those storms can maintain their strength. But those 3 areas right now, it's going to be, if you look over to the left here, it's going to be this storm, and west of Altus. So this storm all have potential to go tornado warned as well in the next several minutes. So if you live in like Hobart, Roosevelt, Altus, Snyder, you guys need to be thinking about having your safe place ready ahead of time. Go ahead and start preparing now. The one thing that is kind of sketchy about this event is even though these storms are elevated, there is a high amount of wind shear, and that high amount of wind shear does allow for the potential of some strong tornadoes up to EF2, maybe even stronger, to happen. So when you see the radar shift like that, I'm actually scanning up into the atmosphere. So right here, I'm closer to the surface. I'm scanning at about 2,500 feet off of the ground. Let's see. We'll do this. So this, oops, that's really tiny. This green marker here is roughly 9,191 feet off of the ground because, okay, so here is our radar site right here. And the further you go away from the radar site, the farther up the radar beam is off of the surface. So let's say we want to look at this rotation right here, this green rotation near Mangum. That is sitting at 9,191 feet off of the ground. Or, no, I'm sorry. Hold on. That is sitting at 3,740 feet off of the ground. The southern one is 3,608 feet. I didn't realize that when I was drawing with my pen that it wasn't showing the correct altitude of the beam height. So yeah, this southern one is 3,608 feet off of the ground, and the north one is 3,745 feet off of the ground. So that's why storm spotters and chasers are so crucial for their data, because we don't always know when or what a storm is doing just by looking at the radar. We can have a good guess, but like we get bad scans and invalid data all the time off of these things, just because I mean you get a high precip loaded storm and it's going to interfere with how far you can see into the storm. If you got a hill or something in between the radar, it can block the radar beam and give you a bad scan. Or you get into this problem on the right hand side of the screen. You see how this looks all distorted and stuff right here? Well, that's because it's range folding right there. So that's always fun. There's just a lot that can go wrong when you're looking at radar versus when you're looking at things in reality. We do have a thunderstorm wind report of 59 miles per hour in Washita, Oklahoma via Mesonet. So we do have a tornado warning remains in effect until 11 p.m. for northeastern Washita and south central Custer counties. Hazard is a tornado and half-dollar sized hail. Locations impacted now include Corn, Clinton, and Bessie. This includes Interstate 40 between mile markers 60 and 73. Take cover now. We also have a tornado warning still in effect for northeastern Custer and west central Blaine and southeastern Dewey counties in Oklahoma until 11:15. The hazard here is tornado and golf ball sized hail, and the locations here impacted include Thomas, Custer City, Oakwood, Eagle City, and Fay. Take cover if you are in those towns or near those towns. So one thing that we can do. Hello, hello, Midwest and Great Lakes storm chasers. I bet I know who you are. Yep, I figured that was Aaron. What you doing, Aaron? So far, I'm a little underwhelmed by my target. I was targeting kind of the southern mode down here. We got tornado warnings up here, but they are very high precipitation, probably not very visible. I haven't seen any storm chaser feeds on it or anything, so I don't know exactly what they're seeing out there, but it can't be much. But really, this rotation by Mangum has been trying to organize for a while now. This whole southern portion of the line is definitely trying to go QLCS. It's just it hasn't hit those prime dew points yet out ahead. We're sitting at 61 dews, almost 65-degree temperatures out in front of it. That's Kiowa County near Hobart. We've got 59 dews to the north and 62-degree temperatures. We have a nice southeasterly inflow of 30 or 46 mile per hour inflow. Well, that's saying the barbs say 30 miles per hour, but the data on here is saying like uh oh, it's winds out of the south southeast at 32 miles per hour, gusting up to 46. Might be knots. Either way, it's relatively close to the same thing. Not a huge difference in wind speeds there. Did you see the photograph and the skew that I sent in a chat from the mesoanalysis website? It's locked and loaded. If it can drill through the cap, it's gonna have some pretty strong tornado potential there. Oh, but what I was saying earlier, guys. When I'm at 0 0.4 degrees on tilt, so if I go, oh really? Do you think that you're hearing the cap's gonna erode? Yeah. If this cap erodes, guys, then these embedded supercells are actually gonna be able to ingest ingredients from the surface a lot easier, and they might actually become surface based, even though it's a linear complex on a cold front. These will be able to. There is enough shear present that these could drill down to the surface and actually become surface-based mesocyclonic embedded supercells inside this line. And if that happens, then the tornado risk is really going to go up. Right now, this kind of a low-end tornado threat right now on this southern portion here. Um, we do still have 2 active tornado warnings, but if the cap erodes to the south here, and these become more surface-based, I'd really be worrying about people in Hobart, Roosevelt, Altus, Snyder, and areas east and northeast of that, um, because this line, once it gets going, it's not gonna stop. Uh, it's gonna take a lot to stop it. Like this storm that's happening now is gonna be the storm that happens down in Louisiana and Arkansas and Mississippi tomorrow for the I don't even remember what the risk is for that over there. Let me check. Yeah, for the enhanced risk, it's going to go all the way down into um, Louisiana, Mississippi, Alabama. Uh, yeah. So I mean, it's going to be a really long night. Oh yeah, absolutely. Like I was looking at the effective SRH earlier. There's 700 knots of SRH, or 700 meters squared by second squared, or whatever, of SRH, which is absolutely enough SRH. Critical angles are pretty high. Bulk shear is fairly supportive of supercells. But we're gonna scan up into the atmosphere a little bit more and see if we can spot some hidden. We'll go back a scan or two. See if we can spot some hidden updrafts here. Did I change? No, I'm still on the same radar. Okay. I mean, really, this is more of a broken line segment right now, so we're still not even technically fully QLCS yet. And these southern cells are struggling. See, there's an outflow boundary pushing off. Okay. Yeah. Okay, so outflow boundary is pushing, oops. Outflow boundary is pushing off from these. So that kind of, I'm not going to say that those cells aren't going to tornado, but they have less likely of a chance to tornado. This storm, however, will have an increased chance to tornado if the outflow from the southern storms can latch if this storm can latch onto the outflow to the south, then it'll actually feed off of that outflow boundary and cause it to rotate. It'll ingest the outflow as inflow. Which that's kind of what it's looking like it's doing, because we can see that outflow starting to push off from here. So we have this kind of thing going on, and then a bunch of outflow winds pushing behind it. And it's pulling warm air from the front up in, like this. So we're getting that spin right here. So that could form some sort of hybrid supercell right there. New severe thunderstorm warning. They did update this northern tornado warning. Tornado warning remains in effect until 11:15 p.m. for northeastern Custer and west central Blaine and southeastern Dewey counties. Hazardous tornado and quarter-sized hail. This is still radar indicated. Locations impacted include Thomas, Oakwood, Eagle City, and Fay. If you are in these locations, you need to take shelter now. Tornado warning remains in effect until 11 p.m. for northeastern Washita and south central Custer counties. Hazardous tornado and half-dollar-sized hail. Locations impacted include Corn, Clinton, and Bessie. This includes Interstate 40 between mile markers 60 and 73. Take cover now. Oh yeah, it's gonna be a long night. This is just the beginning, dude. Absolutely. Like when these storms start getting down into like central Oklahoma, southeastern Oklahoma, it's really gonna be crazy rock and rolling. And then I mean, it's not even gonna stop. It's gonna go straight into day two, and day two is gonna be potentially more significant than today is even. Starting to see some really good notching over here. Well, not notching, but like rotation, and it's broad, but it's been persistent since Mangum. It's wanting to bow right there. Yeah, tomorrow's gonna be crazy. It might be trying to cycle something near Granite. Maybe even southwest of Granite. Yeah, if this line ever calms down, I plan on doing yeah, I was looking here. We'll go ahead since this is kind of petering out up to the north here. Um if we get another tornado warning to the south near Hobart and stuff, can you let me know in the chat? Because I'm gonna pop over to analysis and I'm not gonna be able to see anything for a second on the radar. So actually, right now we're at a 988 millibar surface low, which is just completely outstanding for this time of year. Trying to get the dang pen to work here. So 998 surface low. Wow, there's almost a warm frontal feature in Nebraska, in southern Nebraska. That's insane. Kind of warm front, kind of shoots off this direction, if you will. This is actually, look at that pressure tongue. That's insane. So we're gonna look at the temperature, wind, and dew points here. So I'm almost wondering if this isn't more of like a Pacific front dry line and not a cold front. Or is this a double cold front? Because I mean there's this like dry line feature here. But there's a lot of cold air back here. Is this a really broad triple point? I mean you can see all this cold air here pushing down. But then aside of the frontal boundaries, we know that the main boundary that we're watching is that brown line. And then we have all of this moisture that's surging up from the Gulf kind of through there. It actually looks like the moisture is receding. The good moisture is receding. The good moisture is like receding back. If the moisture underperforms on this, this actually might underperform. I mean, we do have a little bit of theta, but not much. We can look 500 millibar. So we're actually enhancing in the 500 millibar that's starting to eject now. Right, right here. Whoops. That's kind of your ejection core. So we're looking at a right exit for this. And the 700 millibar still dry. Very warm, but dry. And then we go down to the 850 millibar. So actually, we still do have some moisture along here. But it's really being choked out of that 850 millibar moisture. I drew that wonky. It actually goes out farther than that. So we got plenty of moisture in the 850 millibar out ahead of it. 925 millibar moisture is outrunning those southern storms. I don't have another color, so we're just going to go bright green again for that 850 millibar moisture. So this is pretty much where I would consider the prime 850 millibar moisture to be. I'll redraw that again in darker color. So basically we're just focusing on humidity right now and dew points. So this area basically is the area that we're watching. In fact, I'll delete everything else but that. Yeah, yeah, I agree. Because as that low progresses, it's actually going to pull more moisture off of the Gulf. Not to mention when the sun comes up and starts heating things up, it's going to be even warmer dew points. And actually, if there's any residual moisture left over for this, it's really going to enhance tomorrow's moisture surge as well. Because we're already going to have these dews in place, and then it's going to pull more moisture up on top of those and really ramp up those dew points. 925 millibar. Yeah, yeah. So, I mean, these still have plenty of stuff to work with. I don't know how long those southern storms are going to last, though, um, given the lack of moisture that they're in right now. We got deep moisture convergence. Yeah, so, like, yeah. I don't see those southern ones lasting much longer. Low level lapse rates are better for the southern storms, but they're not great in general. Mid-level lapse rates are improving actually. We got 8.5 uh, mid-level lapse rates, which is not terrible. LCL heights are lowering on the northern storms, but still elevated on the lower storms. LFC height, they're kind of outrunning that LFC, but the northernmost southern storms that are organized are still in decent LFCs where they're going to pull dynamic or ingest dynamics easier from the surface. We have our bulk shear ahead of the storm is 70 knots, 65 to 70 knots. And bulk shear to the surface, 40 knots, 35 to 40 knots. Storm relative helicity effective still 600 for we're gonna call it this area right here. Still 600 knots of storm relative helicity effective. Supercell composite basically highlighting that area as well. Get rid of our moisture. I'll get rid of that because I have a basic idea of it's basically this area here that I'd be concerned about seeing a tornado over the next few hours. Let's scan this forward and see kind of how they expect this to progress. Wow, this becomes a full-blown, wow. This is going to be an intense storm, guys. When it finally gets going, it's going to be wild. So we'll look at the hodograph map. And that's something you do not want to see out in front of this. Oh my. Those are mean hodographs. Absolutely mean hodographs. It's still sitting at a 90. Conditional probability of a SIGTOR. Violent tornado parameters also very high. So when you see high violent tornado parameters, that doesn't necessarily mean a strong tornado either. It means tornado that could be hard to track. Tornado that has deviant motion. Tornado that's in a highly populated area. Those are all factors that go into the violent tornado parameter. It's like a critical angle. So we do have some 90-degree critical angles as well. Surface vorticity and ML Cape. So we're starting to see some of that, or not ML Cape, but the 0 to 3 kilometer Cape is starting to actually make its way from the north down to the south, and it's actually starting to fill in. So we're getting a little bit more energy at the surface to help with these, help feed these storms, as well as this insane surface vorticity. Um, yeah. Yes, they were. Hopefully I get a chance to sleep before all that happens. This is a tornadic 0 to 1 kilometer elevated helicity index, kind of highlighting those southern storms again. Everything, if you haven't noticed, the reason I'm focusing so much on those southern storms is because all of these storms out here have basically outran all of the parameters. It's these storms that are down here that are still inside those parameter zones. So that's why I'm focusing so much on those. It's not that I don't care about these storms, it's just I don't think they're going to do as much. Depending on how things go in Nebraska, just because there's not a lot of moisture and there's not a lot of cape up there, there is convection going on along the warm front, and anything along the warm front usually catches my attention pretty quickly because usually along your warm front your wind surged from east to west at the surface. So these actually have easterly surface inflow, and if they're moving northeast or north, then those are potentially tornado producers up there. I haven't looked up there, but we'll go check those out on radar here in a minute. Tornadic tilting and stretching, also highlighting those areas. So let's go ahead and like probable conditional probability of a EF0 is very high. Oh, absolutely, absolutely. And what's worse is I get it before you do. I'm not sure exactly what time frame we're looking at for that, but if it's any time in the daytime, it's gonna be a little concerning. Wow, wow, that's concerning. That's concerning. Holy cow. There's a 2. There's a 2. Wow, that's crazy. Okay, guys, I'm freaking out right now because okay. So this is an experimental model. It's something that is it's conditional on a right moving supercell. Um, and it's something that's being tested. It's not something that's fully got all the kinks worked out, but I've seen these things. I've looked at these things for the past year or so, and they're usually pretty accurate for the most part. If it does put down a tornado, it's usually of that magnitude. So we have probability of a EF0 plus, and you see these numbers here are like a brownish red. These are like a yellow, and these are like a pink. So you have low risk, moderate risk, and high risk. Okay. I personally have seen this before. I've seen high risk EF0 potential. That's just the probabilities of what the strength of the tornado would be in that given environment if it sets down. It's not saying it is going to set down. It's just the probabilities of how strong it would be. Then you have probabilities of EF2. So we've got like brown, red, yellow, or brown, yellow, red. So it's like general, slight, moderate, and then high. Okay. So we still have like a 13 here. So that's saying that this portion of the line has a higher chance of seeing an EF2 tornado. I have never in all of my time forecasting seen any numbers on the EF4 plus probability. This is saying that there's a 1 to 2% chance of an EF4. Or I don't even know if it's a percent, it's just a parameter. So 1 to 2 parameter. And they're red, so I mean, I'm assuming that, you know, it's saying something. So it's like, if this does produce a tornado, there is a chance that it could be EF4 or stronger. But that's if this thing can even produce a tornado at this given point in time. So that's interesting. I've never seen numbers on that that chart before. Going into surface observations now. Back some of this out. And we're going to redraw this line. I like surface observations. They're a little bit more detailed and you can get better ideas instead of using the meso low pressure. Whoops. You get a better idea of where things are at. So it looks like this is a cold front that's causing most of this to happen. It's a cold front causing all of this to happen, actually. It's not a dry line, it's a cold front. The cold front is acting as a dry line. Walking the tornado warning. And probably you're meaning they're stepping it down to another storm. Okay, so we do have a tornado warning. Let me go back to my radar screen, sorry. Oop. Okay. Another tornado warning for northwestern Kingfisher County in central Oklahoma, central Blaine County in northwestern Oklahoma until 11:30. At 11:07 p.m., a severe thunderstorm capable of producing a tornado was located 5 miles southwest of Watonga, moving northeast at 55 miles per hour. Hazard is a tornado. This is radar indicated at this time. Locations impacted include Watonga, Hitchcock, and Loyal. If you are in those locations, you need to take shelter now. We did have a TVS down by Hobart. Yeah, there was an embedded. Yeah, so there's some cycling going on in these. Definitely some cycling going on in these. Oh yeah, I can see why too. Ignore the we'll go back to the analysis stuff here in just a second, but I gotta leave it on the screen, guys. So these right here are starting to form updrafts. You can see the outflow boundary here that's gonna be feeding basically everything north of it. This even right here too is rotating and cycling rotation as well. So basically everything on this in this black circle is starting to rotate a little bit more frequently and a little more enhanced. me back to analysis. Yeah, I'd agree. I don't know though, because we have 61 over 59 here. 60 over 57 here. We've got 63 over 61 to the south. So yeah, I'd say I don't know, my gut's still telling me that these are going to be, like anything in this area is going to be pretty significant. Oh man, what is going on in Nebraska? We're gonna take a look at that, guys. We're gonna shift our attention to Nebraska for just a second. This is a special weather statement for nickel-sized hail. Minor hail damage to vegetation is possible. Not seeing much rotation embedded with it, but I did want to take a quick peek at it because this is on the warm front, and warm frontal storms do crazy things all the time. So as of right now, I'm pretty underwhelmed with how this line is performing so far. Not saying that it's not significant and impacting people's lives or anything, but I am saying I thought this was gonna be a lot crazier by now with tornado warnings. We have a 59-mile-per-hour wind gust in Blaine. Source is a Mesonet. We have another 52 knot wind gust, or no, that's not. 59 mile per hour in Washita, Mesonet. Go back down here to KFDR. Southern mode's done. Do have a TVS starting to form again over here, but I think it's a false TVS. Very more than likely false TVS. No. A lot of range folding. They're just in a really bad spot. Yeah. Yeah, absolutely. Like this stuff down here, I'm not even focusing on now because of this feature right there, that outflow boundary. Things to the north of it, though, those do have my attention. Because the outflow boundary seems to be getting choked off, like it's all inflow from this point and outflow from this point. You do have a TVS marker, but I think it's a false TVS. Might not be. Now we play the hurry up and wait game. This is the fun part. Sitting here watching the screen waiting for it to do something. So I guess while we're sitting here waiting, guys, I'm probably gonna get a drink and just chill for a little bit. Probably gonna go quiet and not do a whole lot of talking. My mouth is starting to hurt a little bit after my wisdom tooth surgery, so gonna rest up my mouth in case I do have to read off a warning. I'm not in agonizing pain doing it. Maybe pop a Tylenol and see if that helps. If you guys have any questions, feel free to drop them down into the box, and I'll either respond with a comment on the yeah, that's what I was thinking. Threat might evolve later as it pushes east. Absolutely. Just really depends on how well that moisture stays established, in my personal opinion. But as of right now, the line it started out really looking really good, and we have had a few tornado warnings on it already. But it's really looking like it's gonna like bust up and dissolve. But that's not saying that it's not gonna repop here in the next like 30 minutes or so.
the RAP and the HRRR seem to think that this thing is gonna intensify and become a really gnarly squall line over the next 2 hours or so. So we'll have to wait and see. But as I was saying, I'm gonna go pop a Tylenol and let my mouth rest for a little bit, and I'll pop back on the voice chat when things start getting crazy again.